For problem 22, we want to eliminate the parameter and then describe the curve. So we begin with our two equations, x is equal to 1 minus sine squared of s, and y is equal to cosine of s. So we have y is equal to cosine of s, and x is going to be 1 minus sine squared of s. So to eliminate the parameter, we're going to use this identity here that says that the square of the sine and the square of the cosine, they add to 1. So we have a square of a sine in the x, but we don't have a square of a cosine. So what we're going to do here is first square both sides of the y equation so that we can eventually get our identity. So that's going to be y squared is equal to cosine squared of s. And what I'm going to do now is I'm going to subtract the second equation from the first one. So on the left-hand side, we're going to have y squared minus x. So y squared minus x is equal to, on the right-hand side, we're going to have cosine squared of s minus the second part. So minus 1 minus sine squared of s. So when we simplify this, we get y squared minus x is equal to cosine squared of s. And then we're going to have minus, oops, I forgot a parenthesis. Minus sine squared of s is plus sine squared of s, and then minus 1. And now we're going to apply the identity. So y squared minus x is going to be equal to cosine squared plus sine squared is just equal to 1. So 1 minus 1. So y squared minus x is equal to 0. And therefore x, if we bring the x to the other side, x is equal to y squared. So we have arrived at our equation. However, we aren't done because we do need to limit the input. In this case, we're treating y as the input. The reason that we need to limit the input is because the parameter itself is limited. It goes from pi to 2 pi. So this curve, it's not an infinite curve. It has a boundary, and we do need to express that boundary now in terms of y because y is the new input. So let me erase all of this. Let's go back to our original y equation. So our original y equation was y is equal to cosine of s. Now we're just going to plug in the boundaries of s into the y equation so that we can see where it begins and where it ends. So s begins at pi, and let's plug in that lower boundary. So y is going to be equal to cosine of pi, which is minus 1. So that's one of the boundaries. Now let's plug in the upper boundary. So we're going to have y is equal to cosine of 2 pi, which is equal to 1. So we can see that if s is bounded between pi and 2 pi, it therefore means that y, which we're treating now as an input, is going to be bounded between 1 and negative 1. So what we have to do now is we have to describe the curve and indicate the positive orientation since we were able to eliminate the parameter. So this curve, x is equal to y squared, this is just a parabola. However, it doesn't open up, it opens to this side like this. It will open up to the right. So this is a parabola that opens to the right. And now we have to indicate the starting point and the ending point because that will tell us in which direction it is going. So if s is equal to pi, we're going to plug in the lower boundary once more into the two equations. So we know that y is equal to cosine of pi. That is going to be negative 1. And if we plug in pi into the x equation, so x is going to be 1 minus sine squared of pi. And sine of pi is just 0, so that's just 1 minus 0, which is equal to 1. So this is the starting point when s is equal to pi. So when s is equal to pi, what that means is that the corresponding coordinate point is the point x1 and y is equal to minus 1. So it begins at 1 comma minus 1. And now let's put in the lower boundary. So the lower boundary here, when s is equal to, the upper rather, when s is equal to 2 pi, y is going to be cosine of 2 pi, which is just 1. And x is going to be 1 minus sine squared of 2 pi. Sine squared of 2 pi is just 0, so that means that x is 1 minus 0, which is 1. And this is when s is equal to 2 pi. So it begins at 1 comma minus 1 and ends at the point 1 comma 1. So we can see here the trajectory that, because this is a parabola, it would begin down here at the point 1 comma minus 1, and then it would go around and end up here at the point 1 comma 1. So that is it for problem 22.